Hello and welcome to today's lesson on electrostatics. Our learning objectives are to describe what charge is and why we don't normally see its effect, describe how to produce static electricity and sparking, explain how the transfer of electrons between objects can explain the phenomena of static electricity, and explain the concept of electric fields and how it can help explain the phenomena of static electricity. This is something you can try at home. Just rub the balloon against your hair and then hold it next to a Coke can and you'll see the Coke can is attracted towards the balloon. To understand why this works, we have to look a little bit closer at the Coke can. The Coke can itself is made up of atoms, and each atom is made up of subatomic particles, and some of these particles have their own charge. Here we have a diagram of an atom that you may be familiar with. What I'd like you to do is copy this diagram down and then add as many different labels as you can think of. Pause the video now while you do that. Here are some labels that you may have come up with: protons, neutrons and electrons, and possibly nucleons or nucleus. Well done if you got more than 4. Now we're going to play a game called positive, negative or neutral. All you have to do is say positive, negative or neutral when I mention a subatomic particle. Is an electron positive, negative or neutral? You don't have to write it down, just say it out loud is fine, and if you're not sure you can pause the video while you decide. Electrons have a negative charge. Is the nucleus of the atom positive, negative or neutral? Don't forget to pause the video if you need more time. The nucleus of the atom is positive. Is a neutron positive, negative or neutral? Neutrons are neutral. What's the charge on a proton? Protons have a positive charge. What is the overall charge on an atom? The overall charge on an atom is neutral because all the negative and positive charges cancel each other out. Now, going back to the earlier trick with the balloon, the reason this worked was because when I rubbed the balloon against my hair, both the balloon and my hair are insulating materials, and I was able to remove some of the electrons from my hair and have them transfer to the balloon. So just to recap once more, friction between two insulating materials, the balloon and the hair, resulted in the transfer of electrons. This gave the balloon an overall negative charge because of all of the extra electrons. Remember, only the electrons move. Although electrons can be transferred in this way, protons are fixed in the nucleus of the atom and can't move. Which material gains the electrons depends on their material properties. You don't need to know this. Another example would be if we rub an acetate rod with a cloth. Acetate is a type of plastic. The friction causes the transfer of electrons from the acetate to the cloth. This gives the acetate rod an overall positive charge and the cloth a negative charge. Friction between a polythene rod and cloth will result in electrons being transferred to the polythene rod, giving it an overall negative charge and the cloth a positive charge. Once again, you're not expected to remember what type of material will gain or lose electrons. Electric charge is a lot like magnetism. If you have two opposite charges, they will be attracted towards each other, whereas if you have two like poles, such as a positive and a positive, or a negative and a negative, they will be repelled by each other. I'm sure you've seen this one before. After rubbing the balloon on your hair, you can get it to stick to the wall. The reason this works is because the balloon has an overall negative charge, and as it comes close to the wall, the negative charge repels all the negatively charged electrons in the wall. This leaves the side of the wall overall positive because the protons can't move, and so the negatively charged balloon is attracted to the positively charged side of the wall. I will include a link to a FET simulation in the description so you can try it out for yourself. Here is a quick summary of what we've covered. I'd like you to copy and complete it with the words provided. Pause the video now, and when you're ready, press play again and we'll go through the answers. And here's the answer. There are two types of charge, positive and negative. Rubbing an insulator can make it become charged. A body will become negatively charged if it gains electrons. A body will become positively charged if it loses electrons. Metals are examples of conductors. They do not become charged when rubbed. Here are some questions for you to work through in your books. When you're answering these, please focus on your keywords. Pause the video now while you work through these questions and then press play when you're ready. And here are the answers. Again, pause the video while you mark them, and if you've made any mistakes, do correct your answers. It's quite easy to sometimes build up a charge walking on a carpet or bouncing on a trampoline. We only notice we've built up an extra charge of electrons when we touch a metal object and we're earthed. The extra electrons are discharged through the metal object. When we do this, we often feel a small electric shock. Making sure that vehicles such as helicopters are properly earthed and able to discharge any static charge before they're refueled is very important, and if it's not done properly can lead to accidents. We're now going to introduce the idea of electrical fields. Now, a field is something that you've encountered before. We've talked about gravitational fields where an object with mass will feel a force. We've also talked about magnetic fields where if you place a magnet in a magnetic field, it will either be attracted to or repelled by something else. If you place a charged particle in an electrical field, it will feel a force, and we can show the direction of that force and the strength of that force with something called field lines. The closer the field lines are together, the stronger the force will be at that point, and the direction of the force is shown by the arrows. Again, we've got our charged balloon here being used to pick up small bits of paper. And now I'd like to have a go at this question. A plastic cone can attract pieces of tissue paper. Explain how this can happen. Pause the video while you answer it. The cone gains a charge when rubbed due to losing or gaining electrons. The opposite charge is induced in the surface of the tissue paper due to electrons being attracted or repelled. The tissue paper is then attracted to the cone since the opposite charges attract. Finally, we have an extension question on using static electricity when spray painting objects. Think about all of the physics that you've learnt in this lesson and how it could be applied to this unfamiliar situation. This is an extension question, so it's optional, but please try and give it a go. Pause the video now and see how you get on. And here we have the answers. Please take your time and go through these. Do pause the video while you're doing it, and make sure that you add any details to your answer that you missed off originally. That brings us to the end of today's lesson. I hope you found it useful, and thank you very much.